Komal, and this is the demonstration of our computational geometry project. Our group number is 19, comprising me and Dhruv Manchanda along with Himanshu Raheja. So this particular file is the main orchestrator file, which will give the user the option to choose between two types of problem, one being the classic art gallery problem and the other is an extended version of it called the camera placement problem. Now the core of the project is to solve this particular classic computer science challenge along with an extension. Now the question is very simple. If you have an art gallery with a complex floor plan, what is the absolute minimum number of guards you will need to place to ensure every single part of the gallery is being watched? Now the project implements and visualizes two different solutions to cater to this problem. Now the classic solution is pretty simple. So in order to do that, first of all, we'll be having these two major classes called the edge class and the vertex class to store the different edges and vertices of the polygon. Next, we'll be having our file which is called the doubly connected edge list. Now this file has the data structure which is used to represent the complex shape of the polygon. This is defined in this particular file, and it's crucial because it stores not just the vertices and edges but also the relationships that they have with each other. Like, it gives us what the next edge is or which face is to the left. Moving on, after that, we first of all start with the monotone partitioning of the particular polygon that we have. So that is preceded by the trapezoidalization. Both of these things is achieved with the class called monotone partition, which will take the doubly connected edge list polygon as its argument, and it will give us the different simpler pieces of the polygon, which will be monotone polygons in itself. Now this uses a very simple sweep line algorithm to partition the polygon into y monotone polygons. Now the next file that we have, which is the monotone triangulation.java, this will take these simpler pieces from the partition algorithm and then it will efficiently divide them into a set of non-overlapping triangles. Now the triangulation is the foundation for both of our solvers. Now till this, the pipeline is same for both the problems. After that, for camera placement problem, we'll have different files, whereas for art gallery problem, we'll be looking at two major files, one being the dual graph. So we'll be creating the dual graph from the triangulated polygon, which the logic is written over here in this file, and the dual graph that will be created, it will be in the form of a tree. After that, we'll be using the three coloring algorithm to color the dual graph. This, what will do is, then the three coloring colors the vertices of our polygon with one of the three colors, red, green and blue, and the theorem proves that the set of vertices with the least used color is a valid set of guard locations. Now for the camera placement problem, till triangulation, the pipeline is same as we've just seen. The major code is written in these three files, camera placement.java. Here it has the logic of the greedy algorithm that will be used in order to find out the minimum number of cameras which needs to be put at the vertices of the polygon in order to cover the entire polygon, given the constraint that the cameras only have a 50-degree field of view. So here we are restricting the cameras to have a certain field of view, whereas the guards have a 360-degree field of view, and that is how we have extended art gallery problem to a different type of real life problem that we are trying to solve. Now let's move on to the visualization part. As soon as I run the main.java file, I'll be getting two options for the classic art gallery problem, which has a 360-degree vertex card view, along with the camera placement problem. We can choose any of them. This is the GUI that I get for the art gallery problem. Now what I do is, we have an option to enter the number of vertices. Let's say if I enter 20, and if I click on create polygon, I have a different polygon here on the screen. I can click on reset, create another polygon, and so on and so forth. So I can get like multiple types of polygons. Here you can see that the vertices are labeled, the edges are labeled, and the coordinates, which are randomly generated by the code, are also shown on the screen. So I can choose any polygon of my choice. Here, let's say this is one polygon. Now if I want to show you the art gallery problem, let's say if I take the number of vertices to be 15, this is the polygon that I get. And okay, so let's just stick to this. I can click on trapezoidalization. This will give me the trapezoidalization of the simple polygon. I can click on monotone partitions. So these blue dashed lines are the ones which are separating or are breaking the polygon into y monotone pieces. Now the triangulation option is enabled, the rest of the options are disabled. I click on this, These gray lines divide the entire monotone pieces into non-overlapping triangles. I can click on the dual graph option. This red line or the tree that is being represented is the dual graph of the entire simple polygon. Now I can click on 3 coloring, and the red, green and blue shows the 3 coloring. So no two adjacent vertices or no 3 vertices in a triangle have the same color. All of them have different colors. I can click on find guards, and as soon as I click on this, the highlighted points are the ones which show the location or the points of the guards, wherein if we place the guards, the entire polygon will be visible from there. So this is the visualization for the art gallery problem. Now let's move on to the camera placement problem. We can choose the 50-degree field of view. Again, this is the GUI that I get. Here till triangulation, my pipeline is the same, but after that we'll be using an advanced greedy algorithm to find out the camera placements, the optimal camera placements for 50-degree field of view. Let's say if I choose 12 to be the number of vertices, I click on generate polygon. This is the polygon that I get. I can click on trapezoidalization. I get the trapezoidalization of it. Monotone partitioning, the blue dashed lines is showing that. Now the triangulation is shown by these gray lines, as the case of art gallery problem as well. Now here we'll not be creating the dual graph of the three coloring. We'll be using a greedy algorithm to find out the camera placements. So as soon as I click on this, I get all of these different shaded areas. So these shaded areas are the places which the camera is covering, and these pointers that you see here show the camera locations along with the direction they view, and the color matches with the triangle. It means this is the field of view that the camera is able to cover. So this red, purple, blue and green. So these are the 4 cameras that I'll be needing. This was our demonstration of camera placement problem and our art gallery problem. Thank you.